There's a nice tutorial by Henrik Reef Andersen from the Technical University of Denmark. I found it on the Oxford and the UTexas web pages. I'll put a link to it in the description. I was thinking about it because it's based on the idea of Shannon expansions, which gives you something called an if-then normal form. And an if-then normal form is something in between conjunctive and disjunctive normal forms. And it seems as if that ARM conditional execution of 4 instructions is designed to implement BDDs that have been coded this way. You can construct BDDs to represent arbitrary logic. You have one BDD for each output bit, and the BDD is in terms of the input bits or the address bits. So 8, you can kind of compress. If you implemented some logic in an EEPROM, in fact, if you've just written some data into an EEPROM, because they're really the same thing, you can calculate the output bits from the data bits from the address bits using BDDs. And I was also thinking about permutations being decomposable into a series of swaps. And sorting a list is just finding a particular permutation, finding a permutation which takes the list into the correct order. And that's what the bubble sort finds for you. So the bubble sort will decompose an arbitrary permutation into a series of swaps. And I've wondered often about sorting algorithms. What if you had a sorting algorithm where you didn't decide in advance whether you were going to sort the list into ascending or descending order, and you just decided according to how you found it which would be quicker? And then at the end, if you've sorted it the wrong way, you just reverse it. But maybe for your application, you could maybe defer it even further using some kind of duality principle. pigeons, hundreds of pigeons. I was also thinking about slime molds and polycephalum, and the fact that I saw an algorithm for, seemed to be something to do with analysing positions in Go using slime mold computation. It's a very strange world that we live in now.